When an object is subjected to two coplanar forces with magnitudes of 6 newtons and 8 newtons respectively, the resultant force may have a magnitude of what? 0 newton, 1 newton, 10 newtons, or 15 newtons? To solve this, we need to understand how coplanar forces combine. When two forces act on an object in the same plane, the resultant force depends on the angle between them. The magnitude of the resultant force is given by the parallelogram law, but the key idea is the range of possible values. The minimum resultant occurs when the forces act in opposite directions, and the maximum occurs when they act in the same direction. So the possible magnitude of the resultant force ranges from the absolute difference to the sum of the two forces. Let's examine each option. 0 newtons. For a resultant of 0, the two forces would need to be equal and opposite. 6 newtons and 8 newtons are not equal. Even when pointing in opposite directions, the resultant would be 8 minus 6, which equals 2 newtons, not 0. 1 newton. For the resultant to be 1 newton, the forces would need to almost cancel each other out. But the smallest possible resultant is 8 minus 6, which is 2 newtons. 1 newton is below this minimum. 10 newtons. 10 newtons falls within the possible range. For example, if the angle between the forces is about 60 degrees, the resultant would be close to 10 newtons. The exact calculation or a quick sketch can confirm this is a valid value within the range from 2 to 14 newtons. 15 newtons. 15 newtons exceeds the maximum possible resultant. The maximum resultant occurs when the forces align in the same direction, giving 8 plus 6 equals 14 newtons. 15 newtons is greater than 14 newtons and is therefore impossible. So the correct answer is 10 newtons. Remember, for any two coplanar forces, the resultant magnitude always lies between the difference and the sum of the two forces.